Math 3 students, this is Thursday, October 1st lesson, and this is our third lesson this week. You will have a quiz tomorrow on everything that we've covered this week. So if you came to the live lesson, now you're working on your classwork, you know about the quiz. So what I've done, this is what your PDF looks like. So you've got 4 problems here, but I'm going to do mine on my Smart Notes page because I think it's easier to see the chart and the graph. What you can do, though, is you can go over to Desmos on your phone or on your computer, and you can go ahead and graph all of these. I don't know if I can share this with y'all. I'm going to try it. I'm going to see if I can share my graphs with you, because if I can do that, then you can just go over there and get those graphs yourself, or you can look at them. I don't know. See if that works. So I'm going to go over to my Smart Notes, like I said, and I've graphed them, and I've actually, when you go to Desmos, let me tell you this. When you go to Desmos and you graph one of these, go ahead and click on all of the points that you're going to need, because you're going to need all of your roots, your zeros, or we call them your x-intercepts. You're going to need the y-intercept. You're also going to need these local maximums, which are the turning points at the top. So go ahead and click on all of those, so you just have them all on your graph as you're working. So that's what I did. I went to Desmos and I clicked on all the points I was going to need, so that I just need to look at this picture, and I've got my chart right here. So I think I'm gonna work all of these probably with you. I might leave out one and let you try it, though. We'll see. So this is number 1, and I don't have the equation here in front of me, but it doesn't matter, because I know that if I have both of the arrows pointing down, I know that the A value is negative. So I can just put negative up here. I know that the degree is going to be even. I don't know exactly what it is yet, but I know it's going to be even, and that's really what matters as far as the end behavior is concerned. If I go back over to my PDF and I look at my equation, I can see that the degree is 2 plus 1 plus 1. So that's going to be 4. So I know it's even, it's a 4. The 4 doesn't even matter as much as the even or odd. So the end behavior, remember on end behavior, all I'm doing is I'm looking at the arrows. So on the left side, that arrow is pointing down, and it's also going to the left. It doesn't really look like it's going to the left, but it is. It's not, there's no asymptote here, so it is going to the left. That's a negative direction and a negative direction. So my first line for my end behavior is y approaches negative infinity as x approaches negative infinity. All right, and then I'll do a different color over here. So this one that I'm circling in blue, down, and it's going to the right. So that's a negative, positive. Y approaches negative infinity as x approaches positive infinity. Now, I know that I don't even have to look at the graph. I know that if it's a negative A and it's an even, that both arrows are pointing down, okay? If it's an odd degree, then one arrow is pointing up and the other one's pointing down. What I want to look at is the right side to know whether the A is positive or negative. We'll get to one of those and I'll talk to you more about it. I know I talked about it yesterday, and I probably talked about it in the notes again. So zeros and multiplicities. Again, I don't really need to look at the equation. I can look at the graph. The zeros are at this point, and this point. So I can look at those to list the zeros. I do want to look at the equation to be able to list the multiplicities, though. Okay, so I went over and I got the equation. So here's the equation up here at the top. So what I can do is I can look at all of these factors, which are these things that are in parentheses, and I just take the opposite of whatever the number is. Or I can look right here and say, okay, I know it's at negative 4, 0, negative 1, 0, and 3, 0 right here. So those are my zeros. Negative 4, 0, and you can just put negative 4, I don't care. Negative 1, 0. And 3, 0. What happens at those zeros? Well, I can look here and say, well, it passes there. That's passing through, okay? Or I can look at the fact that this is a 1 exponent and know that if it's a 1, that is a pass. So that's a pass. at the -1, it bounces. I can look at the picture or I can look at the equation and see that that's a 2 exponent. A 2 exponent means it's a pass. I'm sorry, a bounce. Bounce. And you can just put a B there if you want to. I don't care. And then at the 3, again, it's a pass. The y-intercept, that's given to me also. It's right there. It is 0, 3. I have no idea why they give us so much room on y-intercept. Local maximum. What I'm looking for there, we'll get yellow. I am looking for turning points at the top of the graph. There's one and there's one. And you can have more than one. So it's this ordered pair and this ordered pair. And so I'm going to make these a different color because you can't. Well, maybe we can see the yellow. Let's see if we can. So my local max, there's 2 of them. One of them is this ordered pair right here, but I'm going to round these numbers. I'm going to do -3.1 and 6. And the other one is 1.9 and 13.7. Okay, so those are my local maxes. My local min is a turning point at the bottom of the graph. Let me see if I can get a good color here. I don't like those. Let's get that pink right there. Okay, my turning point at the bottom of the graph, there's one of them. It's right there. Okay, so that is this point right here. So one of my x-intercepts, one of my roots, is also a local minimum. So I would list that as -1, 0. So you can have a root or an x-intercept that is also a minimum or maximum, local minimum or maximum. All right, let's skip intervals of increase and decrease, come back to that. Let's do domain and range because that's a little bit easier. Domain is going to be, it's going to the left forever, it's going to the right forever. So domain is all real numbers or -infinity, +infinity. Range, okay, so it stops up here at y equals 13.7. And it starts at infinity. So a couple different ways you can write this. You can write y is less than 13.7, or actually want to say 13 less than or equal to, or we can say -infinity to 13.7, and that is a bracket because it's included in the range. All right, now we need to do intervals of increase and decrease. Okay, so I'm going to use highlighters here. I think it's easier to use a highlighter. Increase and decrease is where when you're going from left to right, are you going uphill or downhill? Okay, so going from left to right, I need to just determine, am I going uphill or downhill? Where does it turn? You know, so right here, I'm going uphill. Right here, I'm going downhill. Uphill, downhill. Uphill is increase, downhill is decrease. All right, so let's do green for uphill. So from here to here, I'm going uphill, and then this is down. I'm not gonna color that green. And then from here to here, I'm also going uphill. On these, I'm looking for x values. Okay, so let's make sure we understand that. So intervals of increase and decrease. Intervals of increase is uphill. Intervals of decrease, downhill. And we did these before. And we're looking for x values only. So I'm looking at this right here, that right there, this one, and then these are going to be infinity right here. So my first green interval of increase starts at -infinity. Increase. Green. -infinity. And it stops up here at -3.1. And my second one starts at -1. And we want that U symbol between them. It's kind of hard to put in there. -1 and goes to 1.8. Remember, we're looking for x values. Okay. Let's go with a different color highlighter. Let's go with, I like the red one for downhill. I don't know. I think a red is being negative. So let's see if that's red. Yep. Downhill, downhill. Okay, so the first one starts at -3.1. -3.1. and it stops at -1. That's supposed to be a decimal in there. Then my U symbol. The second one starts at 1.9. And it ends at positive infinity. Because we're talking about x values. So positive infinity. All right, I think that's it for that one. I'm going to go a little bit faster on the other ones. This should be number 2. My a value is positive. My degree is 2, 3, 4, 5. So it's odd, which means my arrows are going in different directions. It's odd, but it's positive. So what that means is that the arrow on the right is going up, okay? So it's always going to be like this, no matter what's going on in here between the arrows are going to look like this. So the right arrow is going in a positive direction, up. All right, in behavior, let's look at our arrows. This one's pointing down and to the left. That's negative, negative. This one over here is pointing up and to the right. That's positive, positive. Zeros and multiplicities, I've got them right here. Here's one, here's one, here's one. There's 4 of them. So I'm just going to put, I'm going to put -5, -3, -1, and 2, because I don't have room to put the ordered pairs in there. What happens at those? Pass, 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 bounce. And you can see it up here too. 1 is pass, 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 bounce. So you can put a P, P, a P, and a B. Okay. The y-intercept is right here. That is at 0, 2. Local max. There's 2 of them. They're the turning points. Okay. And it's the whole ordered pair. Okay. So we're going to round. We have -4.34. So you have decimal between there. And also 0.4. And if you don't get these rounded correctly, I'm not going to count off 2.2. I just want I want to know that you can see where they are. Local minimum. Okay, let's see. I have 1. So they're turning points. Remember, it's where the graph turns and goes the other way. 2 right there. So this number, that ordered pair, and that ordered pair. -2.1 and -1.6. And then this one is 2, 0. Okay, let's come back to intervals of increase and decrease. Let's look at domain and range. So domain, it goes forever to the left and forever to the right. So you can do all real numbers. You can do negative infinity, positive infinity. Range, it goes downward forever and upward forever. So that's also all real numbers. That was easy. Intervals of increase. Let me get my green highlighter. I'm going to do the thinner one if I can. Okay, uphill right there. That's downhill. Uphill. Turns the other way. Downhill. Uphill. There are 3 intervals of increase. And we'll go ahead and color the intervals of decrease also. Decrease. Downhill and downhill. Remember, we're only looking for x values. Okay, let's look at our uphill first, our increase. Let's see, it goes from negative infinity up to this right here. So increase, negative infinity to -4.3. U symbol. There's 3 of these. I'm going to have to like write out here. -2.1 to not negative, sorry, 0.4. And then the last one is from 2 to infinity. All right, decrease, I'm going to do red. Goes from -4.3 to, where does it end? Right here, this one, -2.1. And then I got one more. Negative 0, oh, it's not negative, I said it again, 0.4 to 2. All right, that's it for that one. I want you to pause your video and I want you to try this one. So pause your video, try this one, and then come back and see if you got it right. Okay, so I hope you paused your video at least just to try a few of these, if not all of them. So there are your answers. I want you to check your answers and see how you did, and correct your answers if you got them wrong, since I am giving them to you. And then I'm going to leave the last one for you to do by yourself. So I want you to do this last one by yourself. It does have 1, 2, 3 intervals of increase. It's got 3 of those. And then it's got, 3 intervals of decrease. And it's got 1, 2 intervals of increase, just to give you a clue on that. So I want you to do number 4 by yourself. So this one, this one you're going to do by yourself. And maybe during the live lesson tomorrow, I'll go through that one with you just to make sure that you knew what you were doing. All right.